Let's start out talking about the Excel function NormDist. This is a function that's useful for working with the normal model, and basically it helps you convert statements about x values, or values of a normal variable, into statements about probabilities. The way it works is you just type NormDist, open parenthesis, you feed it the x value in question, you give it mu, which is the mean of the normal model you're interested in working with, and sigma, which is the standard deviation of the normal model, and then the number 1. This fourth component here is a toggle, really. It's either a true or a false, but we'll have no occasion in this class to use anything in that position besides the 1. So once you give NormDist the x value, mean, and standard deviation, it will return for you the area under the normal curve to the left of the x value you gave it. So let's look at an example of where the NormDist function comes in handy. This thing is most useful for hypothesis tests when the sampling distribution in question follows a normal distribution. So that means for proportions. Here's an example. In a poll of 1,047 adults, it was found that 22% smoked cigarettes in the past week. Use a significance level of 0.05, or 5%, to test the claim that less than 25% of adults have smoked within the past week. I'm going to start by interpreting that claim into my null and alternate hypothesis. What I like to do is take a look at the claim. It says less than 25% of adults have smoked in the past week. My alternate hypothesis should reflect that directly. So I'm going to type P, lowercase p, for the population proportion who've smoked in the past week is less than 0.25. Once I've identified that, the null hypothesis is the boundary. So that's P equals 0.25. It's the boundary of the interval defined by the alternate hypothesis. So those are my hypotheses. I'm going to head down here and start filling in some of the essential information. N is the sample size, that's 1,047. P hat is the sample statistic, in this case the problem gave that to us, that's 0.22. And I can compute a standard deviation. Well, when you're doing a hypothesis test, everything you do is under the assumption that the null hypothesis is true. So we must assume, for the purposes of any calculations we do here, that the true population proportion is 0.25. That's why I'm calling this a standard deviation and not a standard error, and I'm going to use the formula for the standard deviation of a sampling distribution of proportions, which is square root of p, so square root of 0.25, times 1 minus p, so times 0.75, divided by n, so divided by 1,047. Close parenthesis for my square root, and it gives me a standard deviation of 0.0133 and some change. Before I proceed with the hypothesis test, I should be checking these conditions. Sample size was 1,047. I'm going to take 1,047 and multiply it by 0.25, because remember, everything I do here is under the assumption that the null hypothesis is true. So I'm not going to multiply by 0.22, I'm going to multiply by 0.25, and I get 261.75, which is indeed greater than 10. And I don't really have to compute this because we know the remainder of that, so 1,047 minus 261 is definitely going to be at least 10, but that would be 0.75 times 1,047. It gives me 785. That's, of course, at least 10. So the rule of thumb allows us to proceed with using the normal model for this inference procedure. So next thing I'm going to do is compute a test statistic. In this case, it's just going to be a z-score. So I'm going to do my p hat value, which is 0.22, minus my hypothesized population proportion, which is 0.25, divided by the standard deviation, we just computed. I'm not going to type in 0.013 because I don't want all kinds of rounding error to propagate through my calculation. So I'm just going to refer Excel to the location where I typed in the standard deviation, which was cell B35. And it'll insert the appropriate number and give me a more accurate test statistic of negative 2.24 and some change. From that, we'll use the NormDist function to compute the p-value, which is the probability, capital P in this case. So I'm going to type NormDist. Since I've already computed the test statistic, I'm going to use that as my quote-unquote X value. So again, instead of typing it in, I'm going to refer Excel to the location, which is B39, where my test statistic lives. Since I'm giving it a z-score, that's my test statistic, it means I'm using the standard normal model, which has a center of 0 and a standard deviation of 1. This is the equivalent of using a table of z-scores to look up p-values, except I'm now using Excel to do it. Of course, my last parameter of the NormDist function has to be a 1. And this is going to return to me an area to the left of my z-score, which is indeed what I want because my alternate hypothesis is p is less than 0.25. If my alternate hypothesis had been p greater than 0.25, then I would have been wanting the area to the right of my test statistic, in which case I would have had to use the complement rule, 1 minus NormDist. In this case, my alternate hypothesis is to the left. In other words, I'm marshalling evidence in favor of the claim that less than 25% of adults have smoked, so I want the area under the normal curve to the left of my test statistic. So I get 0.012. You may notice that since I'm using NormDist instead of a table of z-scores, there's really not a big reason to compute the test statistic unless I'm directly asked for it or I'm interested in directly reporting it. What I mean is that since the NormDist function allows me to put in any mean and any standard deviation, I can simply give it our p-hat value, in which case I'm not dealing with z-scores, I'm actually dealing with the sampling proportions. Our sample has 0.22. The mean should be the hypothesized mean, which is 0.25. That's the hypothesized center of the sampling distribution. And the standard deviation should be the one we computed using that hypothesis, which is located in B35. The last fourth parameter for the NormDist function should always be a 1. And if I push enter, I should get exactly the same p-value that I got before. The first one I computed using mean of 0, standard deviation of 1 was doing the computation in the land of z-scores. The second one I computed using the mean of 0.25 and standard deviation of 0.13 was doing the computation in the land of sampling proportions in this example. Either way, I get the same p-score as we should. So now I'm ready to state our conclusions. We evaluate a p-value based on whether it's less than or greater than the significance level. In this case, the p-value was about 1.2%. The significance level was 5%. So I would simply report my p-value is less than 0.05, hence we reject the null hypothesis, H0. When the p-value is below the significance level, that just means that we have found that this sample is statistically significant, which means we do have enough evidence to reject the null hypothesis. So our conclusion in context is that since we've rejected the null hypothesis, we've ruled that this sample provides significant evidence in favor of the null hypothesis. In other words, I'll write this out in more specific context. This sample provides significant evidence that fewer than 25% of adults have smoked in the last week. So instead of just saying I found significant evidence in favor of HA, I'm giving a little bit more precise. I'm filling in what HA represented. In this case, it represented the claim that fewer than 25% of adults have smoked in the last week, and we find that this sample does indeed provide significant evidence in favor of that claim.